Kia ora, year 11, 12 and 13. Here's the last excellence question from last year's integration paper, and it goes like this. So we're given a diagram, and we've got the graph of a function, f of x is equal to this. So it's a quartic, but it's not too bad a quartic. We can integrate that pretty easily. The hard part about this question is figuring out the smartest way to do it. So we've got the curve meets the x-axis at point P. So that's here. And the line on the graph is a tangent to the curve at the point Q, which has coordinates 1, 1. Find the area of the region bounded by the curve, the x-axis, and the tangent to the curve at Q. So if you look at what we've got here, we've got a couple of ways of thinking about this. One of them is to say, well, we've got two functions. We've got a on the top function and an underneath function. And so the area between them is this one, which we could call f of x, and this one, which we could call g of x. But I think there's an easier way to see what's going on here. Now, for both of these approaches, what we're going to have to do is work with two functions, this one here, which is the curve, but also the equation of this tangent line. And you can see that if I just wanted to find the area from here to here under the curve, if I take my ruler, which for once is something I'm going to do in a video because it's worth it, I'd get not quite the same area. And I think that makes it obvious how we might attack this problem. So let's just take away those words here and that little bit there. What we can do is we can integrate between this point here, whatever this is, and this point here. And then this area in here is just going to be the area of a triangle. So we're going to use half the base times the height. So that's the basic strategy. What we have to do now is to figure out the values of some of these points. So point P is the easiest one to do. We've got f of x is equal to 2x minus 1 to the power of 4, and we want to figure out where that equals 0. So that gives us x is equal to 1/2. So point P has coordinates 1/2 and 0, and that's going to give us one of my limits of integration there, and the other one is going to be here at x equals 1. So we know that we're going to need to find the following integral from 1 to 1/2 of 2x minus 1 to the power of 4, integrated with respect to x, minus the area of the triangle. So let's think about this triangle. What do we need to work out? Well, we need to have the base times the height. The height is really easy. It's 1, right, because of the coordinates of Q. But to get the base, we need to first of all find the equation of this tangent line. Right, so we've got the tangent at x equals 1, and then we're going to have to work out where does that tangent cross the x-axis. Okay, so but those steps are not difficult if you just break the problem down. It really comes back to level 2 calculus at this point. So let's go on and figure out the equation of the tangent, because we know that this integral is going to be pretty easy, right? So the equation of the tangent, well, what function have we got? We've got f of x is equal to 2x minus 1 to the power of 4. F dash of x is equal to 4 times 2x minus 1 cubed times 2, because of the chain rule. That gives me 8 times 2x minus 1 cubed. And we need to evaluate that gradient when x equals 1. So we get 8 times 2 minus 1 cubed, which is 8. Now, there are a couple of different ways to work out the equation of the tangent, but the easiest is probably to say y equals mx plus c. 1, 1 is on the line, and m is equal to 8. So we have 1 is equal to 8 times 1 plus c. C is equal to -7, and the equation is equal to y equals 8x take away 7. So let's go back to the graph. That's looking pretty good. Next, we've got to find this point here. So where is y equals 0? So y equals 0 means 8x minus 7 equals 0, x equals 7/8. Right, so now we're good to finish off the problem. I'm just going to show you a GeoGebra picture to go with this so that we can see it a bit more easily. And I've just blown it up a little bit. So we're going to find the integral. So this point here is 0.5. So the full area is going to go from 1 to 1/2. And we're going to integrate the function with respect to x. And then it's minus half times the base times the height. So we now know that this point is equal to 7/8. You could turn that into an ugly decimal if you want to, but I'm not going to. And here's this triangle drawn very, very badly, but you hopefully get the idea. So let's do, leave this here. 1 to 1/2 of 2x minus 4, sorry, 2x minus 1 to the power of 4 dx minus 1/2. Now what's the base? Well, the base here is from 7/8 to 1. So the base is 1/8 and the height is 1. Right, doing this integration, we get, don't expand it out, right, do backwards chain rule on it. So we get 2x minus 1 to the power of 1/5. So we need to multiply by the reciprocal there. And when I differentiate this, we're going to have a factor of 2. So we also need to undo that. And the area of that triangle is 1/16. So what does that give me? Well, it gives me 1/10 times 2 minus 1 to the power of 5 minus 2/2 minus 1 to the power of 5. So that bit's 0. So it simplifies pretty quickly. So we get 1/10 minus 1/16, which gives me 16 minus 10 over 160, 6 over 160, or 3/80ths. Now, when we've got a question like this, it's really important we go right back to the start and check that we have actually answered what they're looking for. So let's go back to the question. Here it is here, right? We just had to find the area of the region bounded by the curve, the x-axis, and the tangent. So we're finished. So the final answer to that works out to be 3/80. Thanks for watching. I'll do some of the merit questions, but probably not tonight. It'll be over the next couple of days.